Okay, the last thing we're going to do in this course is to try and make the connection between what we call demand and supply, and that's basically a measure. Demand is a measure of how much energy you need, and supply is how you get that energy. So we're going to do that in two parts. We're going to firstly look at the demand side, which is basically in the day of your lives, how much energy you consume, particularly electrical energy, and then we're going to look at a way that you might be able to meet that demand through a renewable technology, that is, generating electricity from solar panels, photovoltaics. So, first part is demand. The spreadsheet I've put up on the Dropbox, which you will open, lists out everything I can think of that you might possibly have in your homes, which I've classified under food, cleaning, lights, and self-indulgence, which are things that I consider to be completely unnecessary for everyone's life. So, in terms of my life, I'm very frugal, I'm afraid, and I have very little energy-consuming things in my home, as you'll see in a minute. But just to explain to you how I've set up this spreadsheet, what we're trying to get to is a measure of energy consumption, which I explained to you is power by time is energy. So, in the black column here, I've listed the power rating of all of these appliances. You know, when you buy a microwave, you have a 750 watt microwave or a 500 watt microwave. That's to do with how much power it draws. So the thing that we need to tell is how long we have that appliance on for. So I've set up this spreadsheet where all you need to do is put in each of the yellow cells how many minutes you reckon you have this on for. So all the yellow cells are the things that you might do. I've only left two of them white, and I don't want you to touch those, and that's the fridge and the freezer. So unless you don't have either a fridge or a freezer, I'd like you just to leave those alone, because fridges and freezers tend to be on all the time and they tend to cycle, so that's why we're not going to play with that number. But let's just let that one go. Okay, so I'll demonstrate this with respect to my own life, and that way you'll see firstly how frugal I am, and secondly how much energy I consume in a day. So this is a 1 day period, and I'm just going to pretty much describe what I think I would do in a day. So I don't own an electric kettle, so that's gone. A fridge is there, I do own one of those, and that's populated. I don't own a toaster, I don't own a coffee maker, I don't even own a microwave. I certainly don't own a popcorn maker, nor do I own an espresso machine, nor do I own a blender and a freezer. So under the food category, the only thing I use is a fridge. Under cleaning, I do own a washing machine, and generally I would run that in the evening, maybe for an hour. So I'll just put 60 minutes in there, and that is instantly going to translate into how much energy that uses. I don't own an electric clothes dryer. Let's assume that occasionally I iron a shirt, not very often. I usually do that around 8 AM, so I would spend maybe 20 minutes ironing, in goes 20 there, and very reluctantly I occasionally hoover. Certainly not for more than 30 minutes. Lights, well, I do all have what we call these low energy CFL bulbs in my home, and generally I'd have 2 or 3 lights on. So I'll just put in here, I'll just assume I have one on for the moment. I'll just give you the picture. So that would generally be on when I get home for about 3 hours maybe. So I'm just going to populate 3 hours with 60 minutes in each one. And then laptops, well, generally I would have my laptop on when I get home, so that would be, say, 60 hours. Let's say for 2.5 hours I have my laptop on. That's 2 60s and a 30, gives you 2.5 hours. Don't have a desktop computer or a computer monitor. I do have a kitchen radio, and that would tend to be on most of the time, so we'll put that on. 60 minutes, 60 minutes, 60 minutes. I don't own a hairdryer, though my lady does, so I shall give her 15 minutes of that. TV, I don't own a TV, so I don't have that. Stereo, don't have one of those. Electric blanket, don't have one of those. Shaver, mine's not electric. Plasma TV, nope. Portable heater, nope. And mobile phone is the only thing I do have, and yes, I charge it occasionally, so we'll put that in. 60, 60, 60, 60. Now, having populated all those yellow cells, that is my extremely frugal life, which I've now translated from the power of each of my appliances to the total energy based on the time that I have those appliances on. So if I scroll to the bottom, this will now tell me on a typical day how many watt hours and how many kilowatt hours of energy I use. Now that is an important number. I've translated it just out of interest to what that means in terms of carbon, and that might be of interest to you as well. Okay, so I now know how much energy I use on one day. Now the question is, how do I get that energy? Well, I've shown you here carbon emissions. That's if I were to get all that electricity from the grid. That is, take it from an energy provider, Scottish Power or something like that. But I have an alternative. What if I tried to generate that electricity myself? Well, here we come to Ecotect. Well, back again, my house. One thing I could do to my house, I haven't done it, but I could do is I could put on my own energy generation capacity, that is solar cells. I could do it on the roof. So what I want to show you here is how I can estimate how much solar energy would fall on my roof, and then work backwards and try and estimate what that would mean in terms of useful electrical energy. And it's relevant, I suppose, to architects because it very much has to do with the size and shape and pitch and tilt and orientation of my roof. And therefore, if I'm trying to make a connection between my architecture and my lifestyle, there's an important spatial quality to that connection. Okay, so to figure out what I want to know, which is the incident radiation, I'm going to go to 3D Editor, and I'm going to pick the surface, one surface of my roof, which is the one at the top. Just to remind you, when you pick a surface, it's useful if you do Control Q, and Control Q will put that arrow, what we call a normal, and that arrow must be facing up, can't be facing in, it must be facing out. And if it's facing in, if you press Control R, then it will swap the direction like that. But we must have it facing out. Okay, once it's facing out, well, all I'm going to do is I'm going to use one of Ecotect's wizards. I'm going to press Calculate and then Solar Access Analysis. So the thing I'm after is instant solar radiation. That's a measure of the amount of energy that falls on a surface. So I've picked my surface. I'm going to specify a period, and this is just for the sake of this exercise. The period I'm going to specify, I've just picked 2 days, fairly arbitrarily. The days I picked are, you'll see it in the spreadsheet, 24th of February and 20th of June. Now back we go to Ecotect. I'm going to pick 20th of June first. I've got it already picked there, 20th of June, it's a Wednesday. And I'm just going to take all day, even though in reality the sun will probably only rise at probably 5 in the morning. But I'll just pick all day anyway. I'm going to press Next. The value I'm interested in is the cumulative value. I'm interested in the total amount of energy that falls on my roof over a 24-hour period. So I'm going to pick cumulative. And again, I want to pick objects in my model, selecting objects only. I've already selected the roof, so that's fine. We'll do that. And I am going to perform detailed shading calculations that will take account of any obstructions that are in the way. I'll do it on a medium. And I again, as before, come to a summary page and I'll just press Display Test Points and press OK to that. Now, it takes a bit of time. Okay, eventually it will say calculation complete. That took 1 minute, 60 seconds. Now, it doesn't actually show anything, but to show what it has calculated, we need to do one more thing. We need to click on Display, and then Object Attribute Values, and then it's going to show me a few things it can show. Well, I want to show 2 things. I want to show the color. Now it will turn it a color, and I will do that again, and this time I want to show the text value. When I show the text value, it's going to show a number there, and that number is what we've asked to show. What is the total amount of energy that falls on this roof on the day that I picked, which was the 20th of June? Now be careful, it's just a measure of energy per meter squared, so each meter squared of that roof, it's telling me will have that amount of energy falling on it. Okay, well, what does that mean in terms of my photovoltaics? Well, let's go back to Excel now. The first tab we looked at was demand. I want to go to the second, not the third tab, which is 20th of June, which I've set up for you. Okay, in this tab there are 4 boxes and they're fairly easy to know what to do. You only have to fill out 2 of them. The first is how much energy fell on 1 meter squared of my roof, and the second is this is how big my roof is. Well, both those numbers we can take from Ecotect. Let's go back into Ecotect. The first number is that number there. It's the number that came when I did the attribute values at 3156. So let's put that. This is how much on that day it fell on 1 meter squared of my roof. And then the other value is, well, how big is my roof? We did that before when you're doing the heat loss, but if you select an object and then click here on selection information, it will tell you what the area of that is. So 28 meters squared in my case for the roof. I'll just put 28 there, and then the spreadsheet does the rest. It works out how many watt hours based on that 3,156 watt hours per meter squared over 28 meters squared of roof gives that amount of watt hours. So now I know that that's how much energy falls on my roof. And this last one is assuming we used photovoltaics that had, let's say, a 10% efficiency. And that means that they're able to convert 10% of what falls on them into useful electricity. This number here is what would come out as electricity. So now after all of that, if we go to the last tab, which says demand versus supply, now I can start to fill those things in. Well, this is the first thing we did. How much electricity did I use today? That's a figure I can get from the first tab. And I used 2.96 kilowatt hours, or 2,961 watt hours. So I'm just going to put it in watt hours, 2,961. And how much energy would I have generated through my photovoltaics? Well, I'll go to the 20th June one. Out of 8836. 8836. Well, that's interesting. That means that on that day, June 20th, I would have generated almost 3 times more electricity than I use. That's pretty good. What about, though, on a different day? Well, the procedure is the same. Let's go back to Ecotect. I'm going to calculate again everything that I did before. Calculate solar axis analysis, incident solar radiation for a specified period. Different period, I'm going to take February now. And the day I'm going to pick, I picked it here, is 24th of February. And I'm still going to pick all hours. I'm going to do cumulative, I'm going to do objects model, form detail shading calculations, do all that I did, and display test point, and again, I wait. Okay, and at the end of that wait, Ecotect now tells me that on that day, 24th of February, now 241 watt hours fell on my roof. So back we go to Excel. 241 is the figure I'm going to input in here. My roof is still the same size. What size is it? Let's just remind ourselves. It's 28 square meters. Back we go to Excel, 28 square meters. And now with that total amount of energy in one day, that's the total output at 10%, which is 674. If I enter that figure into this day, 674, well, on that day, February 24th, I would generate but 23% of my electrical energy demand, which is nothing at all. So obviously, if I do the same thing every day and I consume exactly the same amount of electrical energy, but the day that I'm doing it has a very low levels of solar radiation, well, obviously it will be a very low percentage I'll meet, but on a different day it might be a higher percentage. Or if I position my panels differently, or I have a bigger roof, or I live an even more frugal life, then maybe I can make that connection. And if I can make all my needs met with my own technology, my own PVs, And I might be able to say that I am truly carbon neutral because I don't need to take any electricity from the grid. Wouldn't that be great?